At 0900 hours local time, a Ukrainian drone pilot near Kherson runs his final pre-launch check. Battery, green. Shape charge, secured. 50 kilograms of explosives swinging on a cable beneath the belly of a British cargo drone that started life herding cattle. 4 kilometers of no man's land and 1 river crossing sit between him and the target, this bridge. Unknown to him or the systems monitor behind him, a Russian listening post on the far bank has already picked up their signal, and the drone hasn't even left the ground. 6 Ukrainian first-person view drones, FPVs, launched from the Ukrainian positions half a second later. The first screams across the Konka River at 120 kilometers per hour and dives into a sandbagged Russian position near the far end of the bridge. The frag charge detonates and the sandbags blow apart. What just hit that position is a first-person view drone. The pilot sees through its camera like a video game, except this game costs about $400 per unit, and the controller is sitting in a trench 4 kilometers away. 4 more follow in pairs, slamming into trenches and gun emplacements along the far bank. Smoke rolls across the Russian line. The T-150 drone lifts off and claws into the gap. What just crossed the line is a Malloy T-150, a British heavy-lift cargo drone originally built to haul supplies across the Australian outback. 68 kilograms of payload capacity, roughly 130 kilometers per hour at top speed, about as fast as a car on a highway. 70-kilometer range, electric motors quiet enough to whisper past a guard post. Think of it as a flying pickup truck that someone strapped a bomb to. The Australian ranchers who designed it definitely didn't have this in mind. The ground below is a moonscape. 2 years of shelling turned this stretch of riverbank into something that looks like footage from the Western Front. Craters overlapping craters. The burned-out skeleton of a city bus sitting in a road nobody has driven in months. A collapsed apartment block with rebar fingers reaching from the rubble. The pilot threads the T-150 through the wreckage, the 50-kilogram charge swinging on its cable with every correction. 50 kilos of explosive on a pendulum is exactly as fun as it sounds. At roughly 60 meters altitude, the drone is a dark speck against the gray sky. The FPV barrage is supposed to make sure nobody on the far bank is looking up. The system's monitor screen splits into 2 feeds, and neither one is theirs. Both are Russian FPV camera views, live, showing the incoming Ukrainian barrage drones from the pilot's own goggles. Nobody on the far bank is watching the T-150 crossing no man's land. The suppression is working. If you look here at what's on this screen, this is the Konka 3.0, a Ukrainian-made drone detector that intercepts the live video Russian FPV drones beam back to their operators. Whatever the Russian pilot sees through his goggles, the Konka shows on the Ukrainian crew screen, like tapping into the security camera of the guy breaking into your house. Right now, both feeds are locked onto the barrage, clean. But the T-150 isn't invisible. It's quiet, it throws almost no heat, and at 60 meters, it's barely a speck. But every input the pilot makes sends a radio frequency signal, or RF signal, from the control station to the drone. On the far bank, a Russian electronic warfare operator is ignoring the FPV barrage entirely. He's watching a steady RF emission coming from the Ukrainian side, stronger and more continuous than a standard FPV signal. He picks up a handset and passes the bearing along. The operators don't know it yet, but the cat and mouse game just started, and they're the mouse. If you look here at the system that just found them, this is a SkyPoint 2, and it doesn't jam and it doesn't interfere. It just listens. Every time the pilot touches the stick, the SkyPoint 2 hears the RF signal the same way you'd hear someone on a cell phone in a quiet room. 1 unit gives you a direction. 2 units cross their bearings and give you a building within a few hundred meters. Think of it as caller ID for drone pilots. It doesn't block the call, but it tells you which house it's coming from. A box of electronics that cost maybe $15,000 just told the Russians exactly where to find a drone worth 3 times that, and the crew operating it. And the operators can't know they've been found. The SkyPoint 2 doesn't transmit a single watt, so the Konka shows a clean screen while the Russians zero in on the dugout. The T-150 clears the last stretch of no man's land and crosses the Konka. On camera, the bridge appears, and it looks like someone took a shotgun to a parking lot. Craters everywhere. Ragged holes punch clean through the deck from months of HIMARS strikes. HIMARS is the American rocket artillery system that's been erasing Russian supply depots across Ukraine since 2022. 90-kilogram warheads thrown 70 kilometers downrange, landing within meters of the aim point. Against this bridge deck, it kept hitting the wrong layer. Through the biggest one, the pilot can see the river 30 feet below, and the bridge is still standing. Because bridges are built to take punishment from above. That's the whole point of a bridge. Dropping rockets on the deck is like stomping on a table. You'll dent the surface, maybe punch a hole through, but the legs don't care. The columns holding this span up just shrug that kind of force off. If you look here at what the drone is carrying, the operators have something HIMARS never had, a blueprint of exactly what's underneath this deck. How they got it is a story that will make you want to confiscate every phone in the Russian army, but we'll get into that. The shape charge on the cable focuses everything into a single point, like the difference between slapping water with your palm and poking it with a needle. Every crater in the deck is now a delivery chute. The drone flies over the hole, the charge goes down on the cable, and for the first time, something hits this bridge from the one direction nobody built it to handle. The pilot centers on a hole near the third support column. Through it, he can see the column itself, a thick concrete pier running from the riverbed to the underside of the deck. That's the target, not the road surface, the column. The pilot starts his run at one click out. On the far bank, the two Skypoint 2 units have pinpointed the signal, a dugout 4 kilometers from the bridge. The operator passes the grid to his commander, who runs the math fast. Artillery takes too long. FPVs are quicker, but the Ukrainians have drone detectors and they'll stay inside. He needs them outside. He tasks 2 FPVs toward the dugout, not for the hit, for the flush, and calls for a Lancet to handle the strike once the crew breaks cover. The Chuika screams. 2 Russian FPV feeds appear on the detector, incoming fast from across the river, heading directly for the dugout. The barrage didn't catch every Russian crew, and the screen that was clean 30 seconds ago just became the most important display in the position. 90 seconds until the Russian FPVs reach the dugout. The operators can hear them coming, and that is exactly the point. What they can't hear is 200 meters overhead, circling on a quiet electric motor, waiting for them to run. 2 problems are closing from opposite directions. The Russian FPVs are 50 seconds out, and the T-150 is 1 kilometer from the bridge. The pilot can see the Chuika over the system's monitor shoulder. The 2 incoming feeds getting closer with every refresh. He can't do anything about that. What he can do is get this charge on target before everything falls apart. Then his monitor dissolves. The video feed fractures into pixelated garbage, freezes, comes back for half a second, and locks up. He pushes the stick right and nothing happens. A full second later, the drone lurches east, the charge swinging on its cable, and the pilot is flying blind through a 1-second delay between every input and response. He cycles the frequency on the control station, standard counter jamming, the first thing they teach you. The feed doesn't clear. If the link drops completely, the drone drifts with 50 kilograms of live explosive until the battery runs out and it crashes, wherever that happens to be. If you look here at what just hit the drone's control link, that is a SERP VS-5, a Russian jammer on the far bank. The SERP doesn't bother with GPS. The T-150's anti-jam module handles satellite navigation on its own. What the SERP goes after is the RF control link, the radio connection between the pilot's hands and the drone's motors. It floods the frequency with noise across every band the drone uses and drowns the real signal in static. That's why cycling didn't work. There's no clean frequency to cycle to. A jammer that runs about $40,000 is about to wreck a mission worth $500,000. Drone, shape charge, FPV barrage, mortar support, and 2 operators who took 6 months to train. Effective range, 5 kilometers, and the T-150 is flying straight toward it. But here's the nasty part. Imagine someone holds an air horn against your receiver while everyone else in the room keeps talking normally. That's the SERP. The T-150's controls go to mush while Russian FPVs in the same airspace fly perfectly fine. The pilot has one option. He cranks the transmitter power to punch the signal through. The video feed snaps back, still stuttering, but enough to fly on. He corrects the drift and pushes the T-150 back toward the bridge. But every watt that saves the drone also betrays the crew. A louder transmitter means the Skypoint 2 gets a stronger, cleaner signal. The systems monitor checks the Chuika and watches the 2 Russian FPV feeds tighten their orbit around the dugout. The boosted signal just told the Skypoint 2 exactly where the transmission is coming from. The pilot won the fight for the drone. The price is the Russians know exactly where he's sitting. The pilot knows. He can see the Chuika. The Russian feed circling tighter on every pass. He commits the hover anyway. The charge won't place itself. The T-150 arrives over the bridge and he slows to a hover, scanning for the target crater. Wind pushes the drone 2 meters east. He corrects and hits the lower command. The winch motor starts feeding the cable and the charge drops into the hole. Slowly, steadily, swinging with every gust. On camera, it disappears below the deck, 8 meters down. 7. Every correction arrives with a half second after the wind has already moved the drone. He's chasing the physics instead of leading it. Then the camera lights up with muzzle flashes, heavy machine gun, far bank, sandbag position, maybe 400 meters away. Tracers streak across the frame. First burst low, second burst closer. If you look here at the muzzle flash, that's a Dishka, a 12.7mm heavy machine gun, and it's been ruining people's days since 1938 because ballistics doesn't care about age. A 12.7mm round at 400 meters will punch through light armor, and the T-150 is carbon fiber and plastic. The gun throws 600 rounds a minute. At that distance, the rounds arrive before the sound does. The gunner sees the drone, pulls the trigger, and the impacts are already on the way while the bang is still crossing the river. Shooting at the T-150 with a Dishka is like throwing bowling balls at a piñata. Except the piñata costs more than the gunner's truck and the candy inside is 50 kilometers of shaped explosive. The pilot can't dodge without losing the cable position. Either hold the hover and take it or abort. He calls for suppression. A Ukrainian FPV zeroes in on the flash and screams across the river. The gunner ducks behind the emplacement wall half a second before the FPV blows the sandbags apart. The gun goes quiet, but that FPV came off the barrage. And every time the T-150 runs into a new problem, another drone gets pulled from suppression to solve it. 8 FPVs launched to protect this mission. 5 already gone. The pilot is running a suppression barrage with the change in his pocket. And the Russians are learning the pattern. The barrage has been hammering the same positions for 6 minutes. The trenches the Ukrainians identified before launch. The positions they didn't identify are waking up. The second machine gun opens from a concealed dugout 300 meters south, a position the barrage never touched because nobody knew it was there. The pilot watches tracers drift through the camera frame while keeping his hands locked on the hover. He can't spare another FPV. Back at the dugout, the first Russian FPV arrives. The operators hear the scream of 4 props at full power before it appears on the Chuika. Close, maybe 20 meters overhead. The Russian camera feed shows the top of their dugout from above. Sandbags, netting, the dark rectangle of the entrance. The FPV dives. The counter-drone team in the next trench swings a shotgun up. The buckshot shreds 2 props and the FPV cartwheels into the dirt 3 meters from the wall. The blast showers the netting with fragments, but the sandbags hold. The second Russian FPV comes in low and fast from the north, a direction the shotgun team isn't covering, and detonates against the outside wall. The concussion hits the operators in the chest and knocks the Chuika off its mount. The systems monitor catches it mid-fall. Screen flickers and comes back. 3 more feeds converging from different directions. He grabs the pilot's shoulder. The pilot doesn't look up. I know. He checks his screen. The T-150 hovers over the crater with the column visible through the hole. Cable 6 meters down. 4 to go. Maybe 40 seconds of winch time the pilot no longer has. If the 3 incoming FPVs find the entrance, the dugout becomes a coffin. If the operators run, they're in the open. He lets go of the stick and switches the T-150 to hover hold. The charge dangles 4 meters from the column. Not placed, not detonated. Both operators grab equipment and scramble out the back into the communication trench. 40 meters to the backup bunker, connected by the trench but exposed for the last 10 where the wall collapsed. They clear the collapsed section at a full sprint, 10 meters in the open. The systems monitor hears something he shouldn't. A high-pitched electric whine coming from straight up, getting louder faster than anything that flies level. He looks up and sees a dark shape falling at an angle that doesn't match anything friendly. He shoves the pilot sideways into the bunker entrance. The blast hits the collapsed trench section they cleared 2 seconds earlier. A warhead punches into the packed earth and the shockwave rolls through the trench line like a punch to the ribs. Both operators are inside the bunker, ears ringing, dust in their teeth, but alive. 10 meters from where they were standing, there's a crater that wasn't there 3 seconds ago. If you look here at what just hit them, this is a Lancet 3, and it was the real weapon in this engagement the entire time. 12 kilograms total weight with a 2.5-meter X-shaped wingspan, about the size of a coffee table with wings. It launches off a rail catapult, climbs to altitude on an electric motor, and loiters for up to 40 minutes, circling patient and quiet over an area roughly the size of downtown LA, watching through a Zala spotter drone circling even higher. When the Zala paints the target, the Lancet's operator steers it in through a TV camera in the nose, a grown man with a joystick flying a 3-kilogram shaped charge down someone's chimney. The warhead weighs 3 kilograms. Small, until you remember it's a shaped charge built to punch through the roof armor of a T-72. It had been 200 meters above the dugout for 4 miles. The Chewika never saw it because the Lancet talks to its controller in a completely different digital language than the analog feeds the detector was built to intercept. The shaped charge warhead it carries was built to punch through tank armor at 250 kilometers per hour straight down. By the time you hear the motor whine, you have about 3 seconds. The FPVs were never the weapon. They were the dogs flushing birds from the bush. The Lancet was the shotgun waiting for them to fly. The control station survived. The Chewika still works. 4 kilometers away, the T-150 drifts east to hover hold. Charge swinging on the cable, nobody on the stick. The systems monitor keys the radio. Mortar battery, grid square, fire for effect. 12 seconds later, the first 120-millimeter round hits the far bank with a crack that echoes off the river. Then the second. Then the battery finds its rhythm and the far bank disappears behind a wall of brown dirt and gray smoke. 4 rounds per tube, walking north to south. The Dishka falls silent. The second machine gun goes quiet mid-burst. Russian FPV launches stop cold. For 60 seconds, the only things over the Konka are mortar rounds and 1 British cattle drone with a bomb on a string. The pilot fumbles the control station out with hands that won't stop shaking. Dust from the Lancet is still settling on the screen. He wipes it, punches the transmitter back up, and waits. 2 seconds of static. 3. The SERP is still out there. Then the screen shutters and the feed comes back. Bridge deck, crater, cable still attached, charge still inside the hole. Still intact. He exhales. 4 minutes of not breathing will do that. He takes the stick, nudges the T-150 back over the opening, centers the charge. The cable feeds the final 4 meters. On camera, the shaped charge seats against the support column, and the pilot knows exactly which column to hit because a Russian soldier handed them the blueprint. Not in a briefing, not through intelligence channels. The guy posed for an Instagram photo under the bridge. Big grin, rifle slung, victory pose, and accidentally framed the precise support geometry of every column holding the span up. Ukrainian engineers screenshotted his selfie, measured the columns, and built the shaped charge to fit. Your wife tells you not to post everything on social media. She's right. He hits the release. The T-150 bobs upward, 50 kilograms lighter. He wheels it west, and the T-150 screams for the Ukrainian bank at full throttle. The systems monitor holds the detonator and watches the camera feed. 200 meters, far enough that the blast can't take the drone with it. The T-150 crosses. He keys the detonator. The shaped charge drives a superheated jet of metal and gas into the column at 8,000 meters per second. The concrete doesn't crack, it disintegrates. A shaped charge that cost maybe $300 just did what 6 months of several $1 million worth of HIMARS rockets couldn't. A section of deck sags and drops 15 centimeters with a groan that carries across the river. Not a collapse, not yet. But one more piece of the math holding this bridge together, gone. If you enjoyed this video, Watch our other video to see an even bigger strike in Ukraine. Bye for now.